Okay, this is going to be a very short video. I'm just talking about a couple additional ideas. One is a theorem, and then there's also two examples I want to do. The homework for tonight is also going to be from this same section, section 7-5, numbers 6 through 11. And again, you can do that either out of the textbook or out of the your student companion pages that you may have ripped out earlier in the week, or you can go online and print off the section. Also take a picture of the problems and post it online as well. So we have the one theorem that I didn't cover in class, which actually goes back and is very similar to another theorem when we talked about trapezoids. We had a mid-segment theorem for a trapezoid, where the mid-segment was both parallel and parallel to the two bases, and it was the average length of the two bases. Well, for a triangle doesn't have two bases. So we still have the idea that in the triangle, if you have a parallel side drawn in that's connecting two midpoints, then that segment is going to be parallel to the third side, and it's also going to be half of the third side. So here we have this triangle drawn, and since it's connecting these two midpoints, it's going to be parallel to the other side, and it's going to be half as long. So if this was 2x, it'd be half of it, it'd just be x. And again, you can do that with any numbers. So you will see at least one problem on the homework that uses that theorem. But again, the other two examples that I want to go over are based off of some of the theorems that we did in class. So this one, pretty simple, straightforward. We got some of the sides labeled. Now, on this one, you can use one of your theorems. You don't have to go to the fact that we have similar triangles. We have the triangles, we have the parallel lines, and we're only looking for x, which is on one of the sides that's being split by the parallel lines. Therefore, this parallel line is splitting the sides proportionally. So we can split this up, and those are actually our two fractions right there, and set them equal. So we'd have 12 over 8 is equal to 9 over x. Well, if we cross multiply and solve here, we have 12x is equal to 9 times 8, which is 72. And 72 divided by 12 is going to give us 6. So x equals 6. Again, you could have also simplified before we did cross multiplying. So for example, that could have reduced down to, let's see, 4 goes in both of those, so 3 over 2. Cross multiply and solve. Again, we would get the same exact answer. On the next one, this one is using another one of our theorems. So again, that was side splitter theorem, that's what the book calls it at least. And then this one is angle bisector theorem. So triangle angle bisector theorem. So the angle bisector is splitting this side proportionally with these two pieces. Now, the problem on this one, unlike the one we did in class, x is out here. This is the whole entire side. So I need to rewrite it so that I have a value over here that I can use to solve. So I don't know what that piece is by itself, but if the whole thing's x and this piece is 4, then I know this piece is going to be x minus 4. So now I can set up a proportion. I'd have 5 over 8 is equal to x minus 4 over 4. Again, kind of the same way that I use the parallel line here to split my two values into their fractions for the proportion, I can use the angle bisector to do the same thing and then set them equal. So 5 over 8 equals x minus 4 over 4. Cross multiply and solve. So 5 times 4 and 8 times x minus 4. 5 times 4 is 20. This has to be distributed, so that's 8x minus 32. And then we need to solve. So bring the 32 over to the other side by adding it. When we add that, we get 52 equals 8x, and then 52 divided by 8 gives us 6.5 for x, and that would be our answer. So again, just a couple basic examples. Make sure you get these examples copied and then do the homework. The homework's pretty short. It's only questions 6 through 11, so that's a total of 6 questions. I'm going to go ahead and put the problems up here under the Elmo so that you can see what they are. But again, these are the only problems that I need you to do. You could pause the video, copy this down, or I'm going to take a picture of this, post it to ESB as well. But again, it's straight out of your book. It's from, it's also from the ripped out pages in your student companion. Thank you.